Welcome to Biota Live. I'm Tom Bartley, and this is a continuation of the Biota podcasts. For more information on the Biota podcasts, check out biota.org/podcast. We have our first caller.
Hello, Tom. Bruce calling in.
Hey, Bruce. Long time no chat. We've got a lot to discuss this evening by the sounds of things. But anyway, first, some news and notes. If you too would like to call in, the call-in number is 646-200-0640. We also have an active chat room if folks don't want to call the US number. But if you are listening in, we're going to be talking about a lot of topics, and it would be wonderful for you to call in as well. That number again, 646-200-0640. The episode next Friday, August 8th at 8 p.m. Pacific, is with regards to the history of artificial life and whether it is useful in contemporary artificial life. And this is a relatively hard topic coming on the heels of Artificial Life 11, which will be concluding probably slightly before our recording. However, folks who attend Artificial Life 11 will receive a Biota CD containing this very podcast, about 16 hours worth of this podcast, actually. I heard from the folks in the UK that the 400 CDs arrived and will be going out to every participant in Artificial Life 11, which is wonderful news. I heard from Dimitri Teresopoulos that the CDs also were received at UCLA. I'm waiting for confirmation in the UK, but I'm assuming the Indiana CDs have also arrived. Let's start with future Graytham news and get into the London and Silicon Valley meeting following. On next Monday, August 4th at 7 p.m., Anthony Bucci, Informativeness Incentives in Co-Evolutionary Algorithms at Asgard Irish Pub, which is 350 Manchester Avenue, Cambridge, Massachusetts, the usual location for Graytham Boston meetings. I think they took a month off, but they're starting full steam ahead with regards to Anthony Bucci. Now, Bruce, the London audio has hit the feed in the past few weeks, but you were actually there, and also there was Larry Yeager, Justin Lyon gave a talk. Can you just characterize what the London meeting was like compared to the Silicon Valley meeting or the Boston meeting?
Well, it was, I would say it's pretty similar. We were given wonderful meeting rooms at the headquarters of the British Computer Society right in central London on the Strand, a beautiful building, and Rajan was our host there. Stuart Pollard, I hope I'm pronouncing his name right, who was my host at a talk last year, was also there. And surprisingly, I'm at the top of the elevator, and there it opens, and there's Larry and Levi Yeager walking in, who had just heard about the meeting and are in the UK for a couple of months. And so it was just a tremendous time. Quite similar. I would say there was a similar group of people, which means a mixture from academia, hobbyists, etc. The one difference is that there wasn't anyone, at least we didn't know about, that was building an active artificial life system. Certainly Larry has built them in the past, but there wasn't really much tech talk in the audience about algorithms and implementation.
Do you get the sense that Larry is following the contemporary Polyworld community on SourceForge? Is that something that he still participates in?
I did mention to the group that Polyworld was open source, and he was nodding his head, but we didn't really go into Polyworld much. But obviously, Larry is keenly following artificial life, given that he's there for the conference. And he did say absolutely when he gets back to Indiana and gets reorganized, we can start bugging him. He will come on Biota Live.
Yes, he's been giving me that promise since the last A-Life conference, which is 2 years ago. So around the time of the last A-Life conference, I started bugging him, and when he got back, I continued to bug him. But that bit at the end, the question and answer session where he chimes in, is just wonderful. I think out of all the audio, although I've had the privilege of talking to you a number of times previously, Bruce, with regards to the EvoGrid and these kind of things, but I think Larry's particular insight is very calming and very leveling and really wonderful.
Now, for me, the meeting, Justin did a presentation for about 20 or 30 minutes at the beginning on the sort of commercial aspects of artificial life, which, as you know, I'm not sure that I'm convinced there really is any real commercial application of artificial life that isn't just sort of highly tuned algorithms. But his keenness is certainly contagious. And at one point I said, look, if you want to make money off this, talk to Justin. If you just...
for money, see him. For, hours of talking, see me, or something like that.
I often think, I write about how there might not be a God, the designer tinkering in the universe, but that night I suspected that there was sort of a God, even if it was Murphy's Law, because my slides wouldn't project properly, completely due to a driver problem that's known in Dell laptops that requires extensive registry editing that I hadn't done yet. And usually was solved with a reboot, but this time it wasn't solvable, so I was forced to abandon my visual aids and just stand alone in front of the audience and tell the story of the EvoGrid. And it went a lot farther because of that, it went a lot farther than I'd ever gone before, because I was thinking on my feet.
And all the technical difficulties were thankfully cut for the listening audience. I think it took me about 4 hours total and about 3 scan edits to remove all the startup sounds and other related noises that went through it.
Thank you for doing that.
Not a problem. Well, I do feel that people's time is particularly precious when they listen to these things, and also the element of wonder with regards to Larry's stuff at the end and how it brought it all together. I thought, people really need to listen to the very end of this talk to get the kind of all the ends linking up. So no, it was a wonderful talk, and it was wonderful to have the privilege to listen to it. And similarly, the Silicon Valley meeting, I've been in correspondence with Zan Gill, and she's going to be on August 22nd at Biota Live to discuss the evolution of her ideas. So I didn't want to spoil that with putting out the audio of her discussion at Great Silicon Valley, because I think probably her ideas are still a work in progress. And she emailed me that she got a lot of feedback following that initial meeting, and that will change her ideas for what she presents. But Scott Schaefer's audio went out in the podcast feed today. I'll probably put this out tomorrow, Saturday, so it went out Friday. And Scott Schaefer's presentation was wonderful. Do you get a sense of the kind of logical progression as Scott continues to develop his artificial life using Grey Thumb as inspiration?
Yeah, and I think what was great to see at the meeting, there were some repeat people who are actually artificial life tinkerers, builders there. And Scott, given he's kind of being true to the cause of Grey Thumb in that he's coming and showing stuff that he's made in the previous month. And that is really the idea of the Homebrew Artificial Life Club. That's what you do. So for the audience, for some of the audience members, I think Zan's presentation was more about prizes and the philosophy of artificial life and a lot of stuff. And then there were a lot of other speakers she brought in. For them, it may have been a bit overwhelming. And then, of course, Scott comes in and says, well, here's the working system I just made, and here's what it seems to show. And so that was a good balance, I think, for the meeting. And Scott, I'm always, when I see him, I'm filled with a positive feeling, because he's a man that is so dedicated, and I think that he now has an audience, which is a beautiful, positive feedback thing.
Certainly. And Zan did bring a number of people. I was looking at the photos, and some of the faces looked strangely familiar. There were various Buckminster Fuller connections. Can you describe some of the people Zan brought with her?
Yeah, there was Bonnie DeVarco, who has for many years worked with the Buckminster Fuller Institute, and she was an archivist for Bucky Fuller. And she's actually helping to define the Buckminster Fuller Challenge, which is a design prize. And she's a great old friend of the Contact Consortium. She's on the board of the consortium with you, Tom. Mm-hmm. And she was there, and to get caught up on what we were doing in Biota. There was a fellow, Alan Goldstein, I believe, was very snappily dressed. He looked actually like he and his partner looked like they were straight out of the Deadwood series. Extremely snappy, but in a Western kind of a way, in a dark Western sort of a way. And he was holding forth a viewpoint from, he's a PhD in chemistry, and he was holding forth a viewpoint of this thing called the breaking the carbon barrier.
Yes.
Which, as far as I could understand it, it's something that if you are building life out of things with carbon in them, then it's just biology, and if you're not, then you've broken the carbon barrier and you're building life out of other things. That's what I think he was talking about. Then, of course, there's John Cumbers, who came in on that because John Cumbers is a real synthetic biologist from NASA Ames, and we've heard him in previous Grey Thumb meeting. And gosh, who am I missing? Who was a commentator? Oh, there was Stephen. Gosh, really tremendous guy, also a PhD. Who had come to the previous meeting at the Internet Archive, and my brain is fried at the moment because I've
not a problem.
I've been hammering nails all day building the Vision Hut up on the hillside here.
Yes, I wasn't sure whether we would touch on your new career, but it's certainly, if you go to Damon.com, you can see the updated photo archive of what I think may turn out to be potentially a future location for a Biota conference and potentially other talk fests that go on in the Bay Area. So it's looking very promising.
It really is inspiring, and there's the three zones we decided to call. One of them a creation or creativity, which is this big double-decker hippie bus, and there's this big 30-foot octagonal platform, which is expression, where you're going to have meetings, performances, demos, films. We're either going to have a large geodesic dome there or some kind of contained meeting space. And then the hut on the hill is a place for vision. It's a place for looking out on the valley and sitting and listening to music and reading books. So those are the three axes of the Ancient Oaks Retreat.
Well, for folks who are following Biota Live on a weekly basis, you will know that there were no Biota Lives for the past 2 weeks, and that is because Dick Gordon requested a rush chapter from me. So for the past 2 weeks, I have been writing frantically in order to get the rush chapter to Dick. I passed a copy to Scott Schaefer, and I've passed a copy to a couple of other people, so if you're interested in reading it before it's published, tom@noble8.com. The topic was Welcome to the Simulation, and it was a collection of writing that I'd done probably over the past 18 months that I kind of shuffled together, polished up, and added a new train of thoughts through. And as with the nature-inspired informatics text and also Bruce's writing in Dick Gordon's book, I referenced this very podcast very heavily through the writing. There is a lot of interesting dialogue in this podcast stream, and it's important that some of that is registered in the academic community. I think certainly having Zan on in a couple of weeks, we can talk more about that in terms of her writing and her thinking. But just listing some of the names of the people that I used in my various writings: John Klein, Ken Stauffer, obviously Gerald de Jong, Scott Schaefer, John Daigle, Dave Kerr, obviously Roy Plotnick and Dick Gordon, because they've inspired me in a number of directions. But the argument was based around the idea of Darwin and the pigeon fanciers. And for folks familiar with Darwin, the romantic story of Darwin is that he got on a boat and went around to all these islands. The applied story of Darwin is that he interviewed and talked with a number of hobbyists in order to write The Origin of Species, and that I find considerably more interesting, particularly as we are artificial life hobbyists. So the chapter starts with the idea that we shouldn't just think of ourselves as pigeon fanciers waiting for Darwin. We should be both pigeon fanciers and Darwin. And that sets the tone of the text. I talk in a very abstract sense about a field that I used to observe when I lived in the UK. And this is, in some regard, relating to our next week's topic in terms of the idea that the history of artificial life kind of starts back somewhere in the late 80s, and then there seems to be a number of gaps. Well, having written the history of artificial life and acknowledging the number of gaps in nature-inspired informatics, I thought maybe I'll do things a little differently with Dick Gordon's chapter. And I know Bruce wrote with regards to the history of artificial life, starting with Langton et al. So I thought I'll take it in a slightly different direction and describe the fact that we should start thinking of the real world as actually a simulation environment. And what does that give us? What kind of analysis does that give us? I talk about what it means to be alive in this context and how to derive intelligence from there. I then start talking about vastly intelligent systems, which obviously is part of the narrative in terms of the singularity and my various critiques of the singularity up until now. And I propose a measure to test vastly intelligent systems and how we can use human intelligence, human capacity, or at least human stopping power as a way of exploring these vastly intelligent systems. I then start talking about the new mathematics, which leads into what Dick Gordon was talking about in this idea of artificial non-life. And then something interesting came to me. I heard that Bruce, you and Adam Eremenko had been discussing a CNN article that was published recently, and I think it's been referenced in the Gratham blog as well. And I thought, well, all of this is really inspired by, or in some way, a critique of Nick Bostrom's 2003 chapter, Are We Living in a Simulation? So having discussed the CNN article with a few people, Bruce included, I think I probably mentioned it to Scott Schaefer and a few other folk, I decided to contact the CNN journalist who wrote the Bostrom collection of world intelligences that were meeting to discuss the singularity, and made the point that certainly what we're doing with Biota in some regard is a critique of what these folk are saying, that in fact we could be past the singularity, as I have said in previous discussions, and I thought it was interesting that maybe the CNN journalists would want to get a sense of what was going on with Biota. So she corresponded with me, and that's looking very positive. So maybe there will be a CNN article written very soon. But this is part of the ongoing discussion in terms of how artificial life developers need to almost actively instigate in terms of actually getting the message of artificial life out. And we're going to talk a little bit more about that next week, because I think that fits very heavily into the ideas of history. So for folks wanting to participate, we have a chat room, if you don't want to call the US number, but if you don't mind calling the US number in order to participate with this evening's topic, 646-200-0640. So Bruce, you are dealing with an expert audience now. They have heard all your discussions to date on Biota Live with regards to the EvoGrid, and they have now also heard your presentation at Gratham, London, including the question and answer session, and also as you volunteered a whole lot of kind of mental freestyling that you had to do because the computer wasn't working properly. In terms of the after Gratham, London discussion, there were some photos that I put on Facebook of a dinner that occurred afterwards. What was the general feedback about the EvoGrid as people started to, eat and drink and socialize?
Well, generally, what's interesting is it's almost like the EvoGrid or Biota comes to London because there's 2 or 3 other students in the Smart Lab program. And for the audience, this is I'm now enrolled after 22 years. I'm again a graduate student at a university in London in a place called the Smart Lab, where I can actually work on my PhD, and the PhD is going to be on the EvoGrid. But there's 3 or 4 other students within the program that want to collaborate on the EvoGrid. One of them is a doctor and with a great understanding of cellular biology. And actually, after that dinner, we went on a long walk of London the next day, and she kind of gave me more of an education in how the cytoplasm works. And I realized that my journey is now taking me definitely deep into the country of the cell. And upon returning from the UK, my friend and neighbor here, Nick Herbert, who's a fairly well-known physicist and author, started to give me books. And one of the ones he's given me is a beautifully written book on how the cell works and how evolution works through cellular mechanics. And so I'm now kind of turning my entire focus into how biochemistry works, because it's the one extant set of algorithms and methods that we know generated what we see in front of us. So I'm looking at it from a computer science perspective, but I'm really going to dive deeply into this. And so the discussions around the table were partly about that.
So certainly Dick Gordon has been very critical with regards to this approach. And as I'm sure you've heard his criticism, you're familiar with regards to some of the problems that he's described. But they all tend to focus on the kind of undergraduate education associated with this. In terms of the distinction between the undergraduate education versus someone who's a practicing MD, What additional insight do you think that may answer Dick Gordon's concerns?
Well, what was interesting is what happened during the question and answer session at Graytham in London. I was sort of put on the spot, and I knew when you're in the UK, people are more likely to try to skewer you with tough questions. Right? In Ireland, they're likely to heckle. But North Americans just aren't used to this. But I know enough about. I'm from Canada, so I'm sort of ready for this. I'm going to get some kind of tough question. That's why people don't understand Dawkins, because Dawkins has a razor. He's got a rapier. But that's just the culture of the UK, and you know it from your father, Tom, and from your whole upbringing and culture, that they're really willing to challenge you in politically incorrect ways as far as we're concerned.
You got to have your dukes up at all times, yeah.
You can have your dukes up at all times, and I knew that this would happen. And there's somebody in the audience that what on earth is this good for, and how would you know? What I presented, if the listeners will listen to the EvoGrid, is the EvoGrid deep idea, which is you start from. You don't start with any kind of pre-built genetic codes and phenotypes or genotypes, or you start with a soup, with a digital soup that has the property of maybe a chemical medium, but isn't trying to be a simulation of a chemical medium. It's trying to abstract the properties that may generate what one would think of as an authentic living system through a vast amount of simulation time, but hands off. So it's basically the EvoGrid deep idea is, does the universe mathematically and in principle have the ability through the mathematical workings for things to emerge that are blueprints that can make copies of other blueprints, but that also have a structure around them, a structure of support and a mechanism and machinery that evolves, but without any preconceptions, without any artifice. So this is, of course, what Dick Gordon describes in his chapter in the upcoming book as the origin of artificial life. So artificial life without any pre-built things, just origin of artificial life. And so I was challenged by an audience member about, how would you really ever verify that this was exhibiting the right properties to be called a living system, or of what value is all this? And if you can remember from the recording, it occurred to me that if you let the simulation of the EvoGrid deep run long enough, and you saw structures emerge in what might be considered cells or entities, and those structures started to share patterns with the things that you see in living systems, then you know you've hit something. And then a flash came to me, which is exactly what Carl Sims' creatures were doing. So initially they were just flailing around in a simulated soup, but ultimately all the walking gaits and the swimming gestures emerged that you see in nature. So similarly, if in an EvoGrid deep, if you're trying to evolve a digital cell from scratch, over time it will go from a prokaryote to a eukaryote, and you'll see structures in there that have functions that are like a real eukaryotic cell. And that would be one way of saying we're onto something. It's not just that something has started copying itself and evolving, but function and internal functions and structures have started to emerge that mirror some of what physical chemical biology does.
So this is very interesting. I'm reading a chapter currently as a peer review for Nature Inspired Informatics, which is very heavily centered on genetic algorithms, in this case for recognizing people's faces from deceased skulls, kind of forensic, but also quite fascinating in terms of an application of genetic algorithms. And reading through it, it occurs to me that there is an element almost of Newtonian curve fitting to a lot of these genetic algorithms. The framing of the genetic algorithms as they become more tightly confined really applies very heavily to what you have predetermined in some regard in terms of how you frame the genetic algorithms. But what you're describing here is that the genetic algorithms actually emerge from the soup as well. And do you think that necessarily it will one-to-one with the real world when perhaps the blocky creatures, by their very nature in terms of the movement and the placing of where they were rotating and these kind of things, were really setting up the genetic algorithms to create things in the real world? Or do you think that there may be something new and fascinating and beautiful that comes out of this kind of freedom?
I think there could be. And, well, for instance, one of the applications, one of the few kind of applications that I talk about for artificial life would be, people may know on the podcast that I do a lot of work for NASA. And one of the recent series of projects has been asteroids, Earth approaching or near-Earth objects, as they're called, NEOs. And one of the challenges of going to NEOs with robotic craft or with human craft is that the asteroids are very low gravity. And it's actually quite difficult to design robotics for low gravity walking. So you could use a kind of a Carl Sims-like or Brevet-like simulation to evolve a really optimal low gravity walker, for example. And you get something quite beautiful and unique in terms of design just by simulating an asteroid and simulating the conditions of the surface and how this walker may choose to jump certain distances, not all the way to orbit, but there's a second phase of this, and this also occurred to me in the gray thumb during the questioning, which was, of course, what you do is if you really have a sophisticated, say, a EvoGrid deep cell has emerged, or there's a series of cells swimming around in a simulated soup, and you determine that there's enough of a match-up between the properties of the soup and the properties, say, of chemicals in solution. And you're 50 years in the future, so you have the ability to print out biological sheets. You could print out the very structure of the cell that's swimming around, and you have a little pipette. Basically, it's a reverse pipette that comes out of the 3D printer that has bioprinted or bio-imaged in chemistry a working model of the machine that's evolved in the EvoGrid Deep, and then the pipette just ejects it into solution. And then if it has cilia, the cilia start to move, and the EvoGrid Deep evolved cell just starts to move through the solution. Now, of course, it might implode or it might immediately fail and fall apart. It's very likely. When we were trying to do test tube babies, there were very few successful conceptions in the beginning. That was a pipette operation. But this vision of you really have done it when something swims out of the EvoGrid, swims out of cyberspace, which was a chrysalis of allowing something to evolve quite rapidly relative to life, and it's made extant in the world, and it functions. And that first EvoGrid cell or entity that is able to survive for even a few minutes and move around in a physical environment would be quite an achievement. The first EvoGrid creature that replicates would be quite an achievement, because it wouldn't necessarily be, as you suggest, Tom, it might be a beautiful variation on the theme of a living system that simply couldn't have happened in the early Earth, but did happen, evolved in cyberspace, and actually can survive in atomic space.
So moving from the EvoGrid Deep to perhaps the EvoGrid Paper Thin, Gerald and I had a discussion a couple of Biota Lives ago that concluded with some deeper insight into the EvoGrid in terms of both Gerald and I moving our particular systems into something that could be useful in the EvoGrid. Gerald raised some of his skepticism with regards to the project in terms of integrating Darwin at home into anything that you had described, and this is in some regard as the depth problem as you framed it. But what came out of that was, I said to Gerald, well, surely the start of this is just being able to share our source code. Surely the start of this is for me to say, you're developing planetary spheres. I have planetary sphere algorithm code. Why don't we start sharing the code? And we looked at a number of layers before we get to the EvoGrid that would also strengthen and bring together the artificial life community. Certainly listening to Zan's audio, it occurred to me that the EvoGrid is really the antithesis of an artificial life prize in some regard. I mean, rather than being one winner, the artificial life community that kind of builds in there is, in one sense, letting the EvoGrid decide the winner, but in the same sense, the vast collaboration that needs to occur in getting this project working will benefit all of the participants. In a kind of a heavily applied level, has your thinking associated with bringing in simulators and getting folks discussing and integrating their code, perhaps the XML phenotype, have any of these ideas changed since you've been to the UK?
I think that my original conception is still there, that somehow at least two artificial life developers agree to share to allow objects to go either one way or both ways between their worlds. And however that's done, because one, of course, could wave hands and dream of the ultimate architectures, but what will happen is two developers with enough commonality in their worlds, so i.e. they might be both genetic algorithms, they might be both physics-based worlds, and they determine there's enough affordances between them that they could dispatch creatures or plant objects or whatever back and forth, and then pick them up and instance them in the worlds. And one demonstration project like that is all we would really need to identify the challenges and to also show the community that in principle this is possible, even at a simple level. Your creatures, your ants showed up in my simulated L system forest, or your noble apes arrived and now they're moving around my landscape and they're talking to my Nant creatures. And here's how restricted the environment is. The noble apes won't have all the things that they're used to, and the Nants won't have all the things they're used to. But they're shared, and so that's kind of where my thinking still resides. Is doing that first. Watson, come here. I need to talk to you. Or, the first telephone call.
So this is the difficulty with regards to what Zan was discussing in some regard in her prize framing context that I'll let her talk about more on August 22nd, because contemporary simulators, people such as Gerald, myself, Ken Stauffer, Dave Kerr, John Daigle, the list of names go on, have projects that require a certain amount of time and maintenance, and I think Gerald's plea was in some regard that the first step needs to be just an ability to interchange source code. Now, if this is something where, in order to accept a noble ape into Darwin at home, he needs to have a noble ape interface that I've crafted and passed on to him, then that makes some logical sense. But the other point that he was making with regards to environment, I think, is something that could be an easy initial proof. Now, this isn't the EvoGrid. This isn't the grid part of the EvoGrid. This is more a kind of Evo share or Evo source in some regard. But there needs to be an initial movement that enables the collaborative source code. In the past month, I've posted out with regards to open source licenses and whether we could have a Biota license that would, hold the EvoGrid and other components of projects or entire projects that will want to be contributed as a means to unify and give additional things that you don't get through SourceForge or GNU or any of these other things that would be specially tailored to artificial life developers. But I think there are a number of levels to the EvoGrid that need to be considered, and certainly the nature of practitioners is that they are fundamentally pragmatists, but also pragmatists with relatively limited time in terms of these kind of integration projects. If you were to divide up the PhD over the next 3 years, do you have a roadmap in terms of where you would like to be in a year's time or 2 years' time or these kind of things?
Yeah, and in fact, the roadmap for the first year at minimum is to basically go back to the fundamental sensation that I have that I'm incredibly ignorant on a huge number of topics, and that I have to fill the gaps. I need to learn about cell biology. I need to read more philosophy, more books, say, by E.O. Wilson. I need to go back to Dawkins and Gould, and I need to study noble ape so I understand how it actually works and what it's doing. I need to really ingest a huge amount of material so that I'm informed, and that is really the first goal. So any listeners out there who can recommend readings or websites or simulations to study, I'd need to ingest them. And part of the reason I was banging shingles onto the side of this hexagonal building today to get it done, we've actually now finished it, is the place. That vision hut, or whatever we call it, is the place where I'm going to sit, and I'm going to try to read and expand the mind and fill in a huge number of gaps in my knowledge in the next year to 2 years. So that's phase one. Phase two, and it really depends on our NASA funding. I've got a very low level of funding from NASA, it seems, on a continuous basis for various projects, but is to actually build some almost like either real-time simulations of real simple conceptual simulations or 3D graphic movies to show the EvoGrid, how it might work, how would you get something from nothing, almost like a graphical storytelling mechanism.
So in terms of the theme of getting people not to reinvent the wheel through the immense amount of resources that already exist in the community and also the needs of various people in the community, I was thinking particularly with regards to Jeffrey Ventrella and Scott Schaefer, putting those two together, particularly with Jeffrey's move towards open source, would just be really phenomenal in terms of what was outputted. So in terms of the existing community and the amount of resources that are there, particularly with regards to creating simple simulations, I mean, you have Breve, and obviously John Klein would always be interested and willing to assist with that kind of development too. I mean, there are a lot of projects out there that can probably ease this kind of transition, not make you reinvent the wheel, one more time. With regards to the vast slew of information, I think this is something that is problematic for us all. Certainly with the stuff with Noble Ape, I realized that I needed to do a lot more audio. I'm thinking more about video in the future, but there are just so many different methods now for getting information. Books and these kind of things still seem to be out there and certainly work well in historical context, but increasingly there are a wide variety of other media types and actual interaction. I mean, this is the main feedback I got from your demo of Noble Ape at Greatham, Silicon Valley a couple of meetings ago, was that the application needs to provide the primary form of help and assistance when people are using it and interacting with it. In terms of, again, I'm using Zan's talk from Tuesday. I mean, Zan's model is you find the top 8 people and you interrogate them for a period of time to get what they know, and then you work from there. I mean, is this your plan as well in some regard?
Well, part of what I realize I have to do is sit at the feet of many people, maybe visit laboratories, basically almost setting out as a journalist or as a researcher trying to find. And I did this, actually, I'm just remembering that back in 1994, I drove thousands of miles all over North America visiting labs. I went to the Santa Fe Institute, Microsoft, SIGGRAPH, you name it, Silicon Valley, and I was on a mission to research what would virtual worlds look like if they came to the Internet, if there were multi-user spaces on the Internet, and determined that it was happening, and that I knew who was working on the prototypes, and I knew where it was likely to come from and what the shape it would take would be. And so in 95, I actually formed the Contact Consortium because I said, okay, I see it coming, and it's going to happen. We had a brainstorming session in May of 95 where we cast a wide sweep and said this is what virtual worlds will look like when they come, and everything we thought of in that brainstorming has happened.
So in terms of this being a similar travel, do you think there is benefit in videotaping these meetings and getting the visuals as well? I mean, certainly Al Lundell has been a wonderful assistant with regards to the Great Silicon Valley meetings, and certainly the Great Boston folk do videos occasionally as well. But do you think in your travels having a visual moving picture record of some of the discussions would be beneficial as well?
It would be, and also, this is going to be a challenge for me because I spread myself very thin. I want to tell the history all of personal computing, and I'm doing Timothy Leary project, and I'm doing this and that, and building buildings and doing NASA work. So I'm doing so much at the same time that I'm actually literally going to have to make a concentrated focus about taking a lot of notes and almost writing a diary or a blog. And the blog could contain video snippets. It could certainly contain photographs about the journey for the search for, say, the origins of life. I'm very interested in the origins of the universe, but we can't see back through that yet to really understand that. But the origins of life, who's working on that? Like there's a group at Harvard, for example, that has just synthesized, I guess it's a bilipid layer vacuole in solution. They're trying to create an early cell, like a proto-pre-cell. And that was in Scientific American this month. And some of their bilipid vacuoles are around RNA molecules, and they're trying to do Urey's experiment again, but at the level of real biostructures. So I'd go to places like that and try to understand what they've done, and just try to put the picture together, and then try to write about it.
So in this context, obviously, the vast amount of information, as you've mentioned, your additional projects. I mean, if we can pause a little bit and talk about the virtual worlds timeline in terms of it also being extremely useful for the artificial life community. This is a reoccurring theme in our conversations. But the ability to have a method of collating the kind of information that you'll get through the virtual worlds roadmap, this is certainly analogous to what will be necessary in the artificial life community as well. And in your travels, you would be able to collect a lot of primary resources in terms of seeking out and finding people, and if you get video footage, if you get audio, so much the better. So, I mean, I think a lot of these projects are actually interconnected in terms of a mutual degree of benefit.
And in fact, today I was just contacted by the new executive director of the Computer History Museum, who's been in the job just about a month. And it turns out he's a person who's done major media projects in online media. He's quite different from the past director, and he's very interested in the DigiBarn, and Len Shustek, who's the chairman of the museum, encouraged him to get in touch, which was just wonderful, because I had sent him a note saying, I hear you have a new director, how can I help? And I immediately wrote back talking about the virtual world's timeline and saying if we can build the technology to do these scrollable timelines that anyone can contribute to, you can map the evolution of a whole series of media, including computing history, virtual worlds, and of course artificial life, so that there will be one place on the web that people go to and they can say, I want to learn about Botticelli's symbioorganisms on the Institute for Advanced Study machine in 1950, and it's in there. It's a point in the scrollable timeline. You click on it, and it takes you to resources. Or I want to see when Chris Langton got his loops working on his Apple II, and what's there, so that you can get a sweeping history, or the first noble apes, or the first, what's happening today, so that there actually is a Library of Alexandria kind of a thing about biologically inspired technology in a sense.
And I mean, this fits perfectly into our topic next week in terms of the history of artificial life and how it affects contemporary artificial life, and also the interconnections. You've talked quite a bit about Dawkins, and in some regard, Dawkins was an inspiration for next week's topic, because your discussion with regards to the Biota 2 conference and its impact on Dawkins is really a history that only you provide. Dawkins makes fleeting references but doesn't talk about what happened at Biota 2 and doesn't talk about the ideas that came through Biota 2 and how that assisted his inspiration. It's quite a kind of short note, basically, in his writings. In terms of folk like Dawkins, you've talked about him, but, I mean, obviously people like Larry Yeager spring to mind as well. Who are the historical visionaries that you'll be seeking out with regards to inspiring through the EvoGrid?
Well, certainly, I think I'm drawn. One of the interesting things that happened was one of the institutions that is quite interested in EvoGrid concepts is place called CalIT2 or CalIT Squared, and it's two giant facilities. One is at UC Irvine, one's at UC San Diego. And we were down at UC San Diego, which is a large building full of VR theaters and a 4K projector theater and a motion capture rooms. It's very futuristic. But down in the bottom of the building, on the ground floor, are the servers for Craig Venter's gene bank for his ocean collection, where they're sequencing things in ocean water. And they're all there. All the genetic sequences are there. And our host, who took us around CalIT Squared, said, we're really interested in projects that are grid-centered, that need very, very large projectors, that they have multi-100 megapixel projectors made out of multiple hundreds of, in some cases, of Dell flat screens, all driven by one grid. And they said, we could be an ideal home for something like an EvoGrid. And so I need to go back down to CalIT Squared because we know the director. Galen actually may be working with them on her PhD, but to actually see what resources, how does that connect into the adjacent community, which is literally a mile away. It's the Scripps Institute and all the biotech companies on Torrey Pines Road. It's all there. It's all there within a 10 square mile area in San Diego.
And here's another interesting then. The ROCS cluster folk, who are exactly the people that you're talking about at CalIT Squared, were the people the week before on Floss Weekly, before my Noble Ape interview. So there was a lot of venting in terms of the discussion in Noble Ape and also the discussion following with regards to running artificial life on clusters, which is ultimately the EvoGrid in some regard too. So I think the tight vens associated with this kind of technology and artificial life, both with regards to distributed computing and also with regards to visualization, is certainly felt in a wide variety of areas. The real issue is to have something like the EvoGrid or some facility where folks can contribute organisms or islands or these kind of things into, these vast clusters with the visualization interface. What is your thinking now with regards to visualization in particular in the EvoGrid?
Well, it's a two-edged sword because you have to ask, what does visualization buy you? Visualization, if you're going to run your simulation at the clock cycle of the visualization at the frame rate, then you're going to slow it down unduly. And this is why real artificial life cannot happen in multiplayer games or environments like Second Life, because it's so clocked down that you can't use the intense compute power that you need. And this is kind of confirmed by Will Wright as well, who said, artificial life is, you just run these simulations for a long, long, long time and you can't really understand them or nothing seems to be happening. That they're compute-centered. If they're visualization-centered, then they're at the human scale. So it's almost like if you go back to Origin of Artificial Life challenge of Dick Gordon, and you say, let's just do a almost chemical level simulation and occasionally look into it. So it would be like SETI at home in the sense that it's just a vast amount of data that's interacting, but you get some kind of a portal into it. But it really only matters when you detect a pattern. So in the EvoGrid Deep, it would be running and running and running until someone's computer somewhere or some piece of a grid actually detects that there's something copying itself. Copying and mutating. And then you put your lens on that and you can take a look, because that's a significant event. That's a turning point event in the simulation. So that would be the visualization period.
But here's the critique to that, and I've mentioned this in previous podcasts. The selection pressure associated with artificial life are the monkeys that run the simulations, and they have eyes. And looking at these things, the more aesthetically pleasing tend to be the ones that propagate in artificial life simulations. And I think the other interesting thing with regards to Will's critique of artificial life was kind of mentioned with Chris Hecker. And I think you saw different visionaries within the one project in terms of Will Wright's talk and then having Chris Hecker on the podcast. Because I think Chris Hecker appreciates that what we see in terms of contemporary constraints don't exist in multi-core processors, for example. And in fact, multi-core processors are really screaming for this kind of technology in terms of the fact that you have one processor concentrating on one aspect, and then you have maybe 3, maybe 7 additional processors that are there screaming for additional things to do other than just computing AI and these kind of things. So whilst historically it may have been the case that artificial life wasn't ideally suited for games.
Just interjecting here, something quite exciting, probably possibly for you or for listeners, is I was actually invited. There was a fellow at the Graythumb meeting who actually works at Google. He's a historian at Google, but he invited me to come down to Google and give a talk about artificial life, but specifically about biologically inspired methods that a large organization like Google, which is maintaining a huge grids and clusters, biological methods to help optimize and understand what the cluster is doing and allow the cluster to adapt or the grid to adapt. And I thought, gosh, I don't know much about this area. And he said, look, all we need is for you to talk about the vision of using biologically inspired methods. And then the next day, I'm sitting at Intel with our virtual worlds group that we have we meet with there. And the fellow, I mentioned this just briefly to the fellow at Intel because I realize Intel sells a lot of chips to a lot of people who make servers for Google. And he's a senior level manager. And I said, well, they've invited me to come and talk about blah, blah, blah. And he said, stop. This is a very big opportunity. Certainly we're interested in supporting it because they're one of our biggest customers. But it's a great thing for you. Why don't you come up to Intel in Oregon and sit with our top server people and have them giving you an education in a short period of time of what all the issues are in managing very large server clusters. And then you can synthesize that with your biological or your artificial life ideas and go back to Google. And so I'm sort of a go-between in a sense, or a synthesizer. Maybe this is a little bit of a slight career move for me, and/or this could help in the dissertation.
Well, I think this is the logic behind the Nature-Inspired Informatics book, that basically there are a wide variety of areas, and also at a student level, in terms of educating the next generation of software engineers for these kind of problems with, as we're saying, nature-inspired methods. But with only 2 minutes remaining, Bruce, we may have to continue this discussion on another Friday evening.
More books to read.
Yes, certainly. The topic next week is considerably more challenging in some regard. We are going to be looking at the history of artificial life in a somewhat critical light, maybe a supportive light as well, with regards to how we fill in the gaps and how we actually describe the history of artificial life in terms of moving forward. This is obviously a topic of interest to Bruce and me and probably a number of other folks in the Biota community. So if you want to call in for that, it will be next Friday, August 8th at 8 p.m. Pacific, and it will be just after Artificial Life 11, so we'll be getting a lot of new listeners thanks to the Biota CD drop.
Everybody notice it'll be 88808.
Very much so.
At 8 minutes past the hour.
That's when the real topic will get started. Wonderful talking with you this evening, Bruce.
Wonderful. Thank you, Tom.